Hello everyone. Welcome back to Dr. Lou's VCE Physics channel. Today, let's learn together about the 2022 NHT Physics. We will focus on questions related to light as a wave. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. A whole wave is between ends, so the wavelength is 2.0 meters. Applying the speed, frequency, and wavelength equation, we calculate the wave speed. The critical angle is asked. When the angle of refraction becomes 90 degrees, the light is refracted along the interface between the two mediums. This angle of incidence is the critical angle. Using Shell's equation, we calculate the critical angle. Following filter X, the vibration will be in one direction only. The direction will be horizontal. Following filter Y, there will be no vibration at all. Filter Y only allows vertical vibrations through. So, D is correct. The Doppler effect can be observed not only in mechanical waves but also in all waves. So, B is correct. From the figure, we know that the wavelength is 0.4 meters. We calculate the frequency by applying the speed, wavelength, and frequency equation. After 25 milliseconds, the wave moves forward 0.2 meters. So, all points on the wave move two segments to the right, a half wave. If the velocity remains the same, the wavelength should get shorter. The speed of the microwave is the speed of light. We calculate the frequency of microwaves by the speed, wavelength, and frequency equation. The up pathway has 6 waves, and the down pathway 5 waves. So, the path difference is 1 wavelength. From part A, we know that the wavelength is 0.025 meters. So, the answer is 0.025 meters. Since the path difference is 1 wavelength, a whole multiple of the wavelength, the intensity will be a maximum. If the frequency halves, the wavelength will double. This means that the top path is now 3 lambda, while the bottom path is now 2.5 lambda. As the path difference is now 0.5 lambda, the intensity will be a minimum. As the light ray moves from a region of lower refractive index to one of higher refractive index, it will slow down. When the angle of refraction becomes 90 degrees, the light is refracted along the interface between the two mediums. This angle of incidence is the critical angle. Using Shell's equation, we calculate the refractive index of glass. The index of glass is equal to that of crown glass. So, this glass is crown glass. Students used a double-slit interference experiment to measure the wavelength of light. The independent variable is the distance between slit and screen, and the distance between slits. The dependent variable is the average distance from the central bright band to the first bright band on either side. The controlled variable is the wavelength of the laser. The ratio of L to D is calculated by the equation. Plot the values from Table 1 on the grid and draw a linear trend line through the plot. Wavelength is the gradient of this line. Select 2 points and calculate the gradient. Please note that the factor of the horizontal is 10,000. The unit of gradient is millimeter. If x is plotted against the ratio of L to D, then the gradient is lambda. Since the units of the gradient is millimeters, the wavelength is converted to meters by dividing by 1000. In light as a wave, 4 multiple-choice questions are worth 4 marks, and 4 short-answer questions are worth 34 marks. The overall score for this section is 38 points. With a total possible score of 130 points, the percentage for this section is 29.2% of the total score.
If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel, Dr. Lou's VCE Chemistry channel, and Dr. Lou's VCE Biology channel.